All right, welcome back. And so now what we're going to do is we're going to do an example. I'm going to read this example. So again, write this down in your notes so you can review it and just make sure you be detailed. And I'm going to walk through the setup and then I'm going to work out the problem here. Okay, so again, just be prepared. So I'm not going to write it all out. I'll let you guys do that. Okay, so here's the setup. Okay, it says write an equation for the simple harmonic motion of the ball described above. So that's in the previous video, where the period is 4 seconds. Verify that the frequency is 1/4 cycle per second. So in the beginning, in the first video for this section, I explained a certain example. So now we're going to describe that harmonic motion given the definition in the last video. Okay, so in that we had the displacement, right, was what? Maximum displacement, maximum negative displacement was negative 10 centimeters. Maximum positive displacement was 10 centimeters. So and the equilibrium point was obviously at 0. So in that case, the amplitude A, we know, or the absolute value of A, we know is 10 centimeters. We talked about that. Okay. We also know that the period, right? The period was equal to 4 seconds. And then, of course, the frequency was 1/4 cycles per second, right? And this, remember, period is 4 seconds per cycle, right? And so that was the setup before, right? So that's nothing new. Shouldn't be surprised by that. Okay, but let's verify what we have, right? So this is obviously true given the definition. Remember this, the period was what? 2 pi divided by omega, right? And this is omega divided by 2 pi, okay? And notice that these are reciprocals of each other. So if we use this, 2 pi is equal to omega, well, we can figure out what omega is, right? By just using our calculator. So let me do that right now. Okay, so we're going to do 4 seconds. So what we'll do is omega equals 2 pi divided by 4, which is going to be approximately equal to, let's do this right now. So it's going to be 2 times pi divided by 4. So it's approximately 1.57. 1.57. Okay, now that's an approximate. So what I would do is if it asks you for approximate value, you would just write that out to however many decimal places. So some of the problems might want you to do that. And then of course it would be a time, right? That would be the period would be the time. So this would be in seconds. So it would be approximately 1.57 seconds. But if we wanted the exact period, then we would just write this as pi over 2. Okay? And so now, all we have to do is, we've got omega, we know d, right? This is d. So now all we have to do is write our our harmonic motion, right? So that would be D, or excuse me, not, this isn't D. We're going to write D, right? The distance, right? The distance changes with respect. So D is the function. So it's D is a function of omega. So it's going to be D equals, and we're going to write 10 sine of what? It's going to be pi over 2 times t, right? Because it's a function of time. Okay, displacement is a function of time. And so that is the answer. Now, note that the choice of A equal to 10 or negative 10 depends on whether the ball initially moves up or down. Okay? And to verify that the frequency, note that what? If I write the frequency, so frequency, again, we already showed this, but let's do this. So frequency equals what? Frequency equals omega over 2 pi. And so again, omega is pi over 2 divided by 2 pi. Right? Which then equals what? Pi over 2 times, 1 over 2 pi, which then equals pi over 4 pi, which then equals 1/4. And so we just proved what we already know, which is the frequency is 1/4 of a cycle per second. All right. Have a great day.